Hello everyone. In this video we are going to discuss about the applications of the XOR gates. Okay, so in the interviews may ask this question to test your presence of mind, or how you are looking at the particular one gate, right. So if the XOR gate is there, so simply you are looking at if both the inputs are different, it will be 1, and both the inputs are same, it will be 0, something like that. Not only one perspective, and if you have more than one perspective with respect to the particular thing, so they will test your that scenarios there. So for that you may can do some analysis from the truth table itself. So truth table itself you may do some analysis to provide your answer. So we'll just discuss about that. So how for the XOR gate. Okay, so the XOR gates, what and all may be the applications. So we will just discuss about that. First, for that we'll just write the truth table of that. As we know, it will be 0 0 1 1 0 1 1 1 0. Okay, so if it is the same, it will be 0, and if it is different, it will be 1. Okay, so from this point itself, okay, we'll just talk about one by one. So first you check in this perspective, like if you see, right, this is 1 bit input, this is another 1 bit input. So here we are getting 1 bit output. This is what we have, right? So first you see how that particular inputs are getting converted to this output, right? So how it is getting processed. If you see here both are equal, so that time we are getting output as 0. If both are equal, output we are getting as 0. If both are different, so we are getting output as 1. So there is one thing is called one particular application, what we can list it out as we can list it as like this one, comparator. So this symbol also we can use for XOR. Okay, XOR B, it can be, how it can be, if both are equal, it is getting 0, right? So then A not equal to B, right? That means if both are different only, it will give output as high. So if you have to design one comparator that need to give A equal to B, only when both are equal it need to give output as high, means what you have to do, the comparator here it's out. So if the specification is like this, out should be 1 if A and B equal to B, A and B are equal, and out is 0 if A not equal out equal to 0, if not equal to A not equal to B means. So this is the requirement specification, means what we have to do, we just have to have some XOR gate here followed by one NOT gate, and this is our output, and this is A and this is B. This is simple comparator which follows this specification. This is the specification for that. Okay, so this is the specification for that. If they provide the specification, so you can come to know, okay, if out should be 1 if both are equal. So but here it is just an invert of that. So same like that, output equal to 0, they are expecting only when the A not equal to B. So how we can just, instead of saying this as this NOT gate, we can just simply mention as XOR. So and XOR is not like it's just an inverted version of that, right? So we can have like comparator this one using our XOR or XNOR. So this is one of the application, or anything. This specification may change. Say sometime they ask out equal to 1 only when both are not equal, out equal to 0 only when both are equal. So if they ask like this, so that time we can just directly use the XOR gate instead of XNOR gate. Okay, so this is based on the specification. We just compared our truth table and we got this. Okay, so this is one of that. And we'll go for another one. Okay, another one application, or another one application where it is getting used. So you may see that two-way switches in your homes, right? Like two-way switches, what it will do, you will be having, so in your home you will be having like consider you that is that particular two-way switches for to turn on your motor, something like that. So switch 1 will be located in some places and switch 2 may be located in some places. This is to give you comfort, like in any of the from any of the places you can able to turn on or turn off the switches, like that. If you want to do the two-way switches, so in two places of your home you will be having two switches. So what it will be expecting the operation is, right, so it will just if I toggle, yeah, this is switch 1 and this is switch 2. Okay, now I am in the place of switch 2, like switch 2 is in upstairs, I am there. So that time consider this is in upstairs, this is in downstairs. So this is okay. So if we are here means what we will be expecting, we will be turning on, we will be operating only switch 2. We won't be operating S1. We were unable to operate the switch 1 since we are in upstairs, so we will be operating only S2, right? So that time here it can be anything, don't care, you put don't care, it can be anything. But if I currently in my state also you consider, currently your state is like currently the light is off already. Okay, the light is off means it will be 0, right? So if it is 0, and consider this also first y, don't care, this also y, it can be anything, and this also can be anything. So what we will be expecting, if this is x, this is some another don't care, and this is some another don't care. If I use this particular switch, if I just turn on or turn off, if I just do this one, what I should be having here, I should be having my output, already available output as y bar. If it's previously, if it is 0, it should be 1, and previously if it is 1, it should be 0. Like if it is on, it should be off, if it is off, it should be on. Okay, so this is what we will be expecting. Same as the case, okay, no, not like this. So if I just switch, I have to toggle this, right? So if I just toggle this from 0 to 1 or 1 to 0, anything I can do. So that time my output also should toggle to y bar. Okay, so it can be anything. So that time if I change my input to 0 to 1 or 1 to 0, it should be toggling, it should be 0 to 1 or it can be 0 to 1 or 1 to 0, anything it can happen. Same like that, if this is some don't care, I am here means, so that time also I will change my input to 0 to 1 and 1 to 0. So that time my output, that time again also it need to be, if it is y bar previously, it need to become as y. Just a toggling need to happen at the output when any one of the switches, when we have one of the input as stable and another one input is changing, so my output need to be toggled. Okay, so that is what our expectation. Now consider our XOR gate. Okay, so here what we are having, okay, so consider this is the scenario, this is my switch 1. So now switch N is in off condition. So and my switch B also, like S2 also is in off condition. So that time I have to turn on my thing, right? So that time output also previously it was this one. If I like to turn on, what I will do, I will change my switch 2 to 0 to 1. So that time my output also will toggle. Okay, then same, if this we are not touching, so this time if I change from 1 to 0, my output also will go to 1 to 0. Same like that, if you see this, this is already in on condition, so that time also if I go to 0 to 1, the output will go to 1 to 0. If I go to 1 to 0, the output will go to 0 to 1. This is what it will happen. Okay, so same as the case, if you see with the S1 also, so here it is 0, this is 0 0, right? So S2 is constant now. If you change this input to 0 to 1, that time your output also will toggle to 0 to 1. And if it is become 1 to 0, then your output also will become 0 to 1. Same as the case with the 1 also. So here and here it is same. So if it is changing from 0 to 1, your output will change from 1 to 0, and if it is 1 to 0, this will change from 0 to 1. So if one input is stable and another input is toggling, means it will just toggle the output from the previous state. So that is what the XOR gate is doing. So we can directly use the XOR gate as a two-way switch. Yes, so this is one of the application. Okay, this is one of the common applications. So, and one more we can this is like most asked interview question actually. So this, they will ask you to implement buffer or inverter using XOR gate. Okay, only using XOR gate they'll ask you to here if they ask XOR gate also you can manage, right? So this is just an inverted form. So if you need they ask us to do with the XOR gate means, so that time just an extra inverter will need to be there. Okay, so now buffer or inverter using XOR gate we have to do. Okay, so for this consider again we'll go with the truth table only, truth table method only. We no need to worry about any other thing, only truth table is enough to prove this also. Okay, now they are asking like buffer or inverter, right? So anyway for these two particular applications we need only one input, but for XOR how it will be having, it will be having two inputs. So this process how we will consider one particular input as constant, like it is same as the previous approach. Here A is 0 in both the cases, right? So consider A is 0 only, so this is not our primary input, so B is only our primary input which is coming from the external side or board or anything. So that time what is my output is getting same as B, right? If you observe it will be same, what is the B value we are getting, it will just populated the output. Same as that, if it is 1, what it is doing, it just inverting that. If it is 0 it is inverting at 1, if it is 1 it is inverting as 0. So if A equal to 0 out will be B, and if A equal to 1 out will be the B bar. So this is how we will be implementing the buffer or inverter using XOR gate. Okay, so this is what about the XOR gate application. So yeah, here discuss 3. So but if anything they are asking means you can just write the truth table, and with that we can able to implement the particular functionality what they are asking. Okay, this is about this one. Thank you.